So the last part of this lesson, and again, as I mentioned at the beginning, I'm not going to prove these half angle formulas. I'm just going to use them. And what you should notice in all of these, at least the first one of tangent as well, is they all have plus or minus with them. You're not going to do plus or minus. You're going to choose either the positive version or the negative version, but we have to make sure we know what quadrant our half angle is going to end up in, and that will tell us if the ratio that we should use is positive or negative. So let's try this one. We're going to do three different ones. We're going to do sine of alpha over 2, or 1 half alpha, the cosine of 1 half alpha, and the tangent of 1 half alpha. So the first thing I notice is it says that tangent of alpha is 8/15, and alpha lies in quadrant 3. So if I were to draw this, it's in quadrant 3, right? And here is our alpha. And it says tangent, which is opposite over adjacent. So opposite side 8, adjacent side 15. But what we should notice is that we're going down in the y direction and to the left in the x direction. So they're both negative. The reason that kind of gets masked is because when you divide -8 over -15, you get a positive fraction. So that's why it can be a little tricky there. So let's find the hypotenuse, or my letter r, by doing -8 squared plus -15 squared equals r squared. So 64 plus 225 equals r squared. So that's going to be 289. And if you don't know the square root of 289, you can look it up in a calculator, but it's 17. This is 17. All right, now r is always positive, so don't need to worry about that. So now, before I start doing these, the last thing I want to check is where would the angle alpha over 2 reside or terminate? So it said that alpha was in quadrant 3. So if I draw a quick little sketch here, in quadrant 3 would be between 180 degrees and 270. So what you do is you divide both of these numbers by 2, and that will tell you kind of the range of values that we can have for our alpha divided by 2. So we have 90, right? 180 divided by 2 is 90. 270 divided by 2 is 135, which is right here. So really it's this kind of area, right? These angles between 135 and 90, which you should notice is that is in quadrant 2, right? So we'll use that information to help us answer these three questions. So number 1 says the sine of half of alpha, or alpha over 2. So I'm going to write down my formula, which is the square root of 1 minus cosine of alpha over 2. Now, before I start plugging in stuff, decide, is this going to be the positive version or is it going to be the negative version? And what I notice is we're in quadrant 2, right? We decided at the end of the day we're in quadrant 2 for our half of an angle. So if we're in quadrant 2, right, all students, S for students, S for sine. So this will be the positive version. All right, so let's plug in cosine of theta. So 1 minus cosine, I guess I should say alpha. Cosine of alpha is going to be adjacent side, so -15, over the hypotenuse of 17. So minus -15 17ths all over 2. Then I'll do that again. All right, and which is 1 minus a negative is really addition. And I want to get a common denominator, so 17 17ths would be 1. So 17 plus 15 is 32 17ths, right? And we're dividing by 2. Again, I'm never going to divide by that 2. I'm going to go ahead and multiply by the reciprocal, which is going to give me times 1/2. The 32 divided by 2, when I look diagonally, is going to make the square root of 16 17ths. I do know the square root of 16, that's 4. And I don't know the square root of 17. So this is the answer. But if you get a common, or I should say, if you rationalize the denominator, you get positive 4 times the square root of 17 over 17. So this is my final solution. All right, and notice we use the positive version, right, the whole time. All right, so that's our final answer there. Let's do 2. Cosine of half of alpha, or alpha over 2. All right, remember, I'm going to copy down the formula, 1 plus cosine of alpha over 2. Again, decide. We're in quadrant 2 where sine and cosecant are positive, so cosine is actually not positive. This will need to be a negative. So the opposite of 1 plus the cosine of that, which is negative 15/17 all over 2, which is equal to the opposite of. So 17/17 minus 15/17 is 2/17. And we're dividing by 2, which is going to be multiplied by 1/2. The 2 over 2 will cross out and get me 1 over 17. I do know the square root of 1, right? Square root of 1 is 1 over the square root of 17. Rationalize the denominator, and you get the opposite of the square root of 17 over 17. So that's the final answer for 2. Let's do the last one, 3, which I believe is tangent of half of alpha. All right, so tangent of half of alpha is going to be plus or minus 1 minus cosine theta, or alpha, over 1 plus cosine of alpha. All right, let's decide. We're in the second quadrant still. Again, so this still needs to be a negative. Only sine was positive. Plug in the stuff that we know. We actually did these already, right? If you remember, we had 1 minus the cosine of alpha, which gave us 32/17 from the first one, divided by 1 plus cosine of alpha, which gave us 2/17, 17/17 plus negative 15/17, which is 2/17. So if you multiply by the reciprocal, the 17s will cross out. I guess I'll just show the work. So times 17 halves. We get the 17s cross out. 32 divided by 2 is 16, and the square root of 16 is 4, but don't forget to bring down that negative. All right, that's it for those half angle identities. Let's do one more, and we'll just, same thing essentially, but just only one. All right, so it's telling me, the first sketch, that alpha is in quadrant 4. So somewhere over here is going to be our alpha. It says the sine, which is opposite, so negative 4, over hypotenuse of 5. And I already know this then must be 3 for x. And we're moving in a positive direction in the x direction. If you needed to do the Pythagorean theorem, you can. All right, so we need to find the exact value of cosine of half of alpha. So again, if it's in quadrant 4, that's between 270 and 360 degrees. So let's cut those in half. If we divide them by 2, we already know 270 divided by 2 is 135, which is in the second quadrant. And 360 divided by 2 is 180. So somewhere in between here, right? And that is in quadrant 2. So just like the previous one, we'll be focused on quadrant 2, where if I do cosine of an alpha or angle, whatever, in quadrant 2 is going to be negative. So I'll make sure to choose the negative version of my half angle identity. All right, so it's going to be the negative version of 1 plus the cosine of alpha over 2. So let's plug in what we know. We know that the cosine is going to be the adjacent side, so 3 over the hypotenuse of 5, so 3/5 over 2. Let's add the tops. So we get 1, which is really 5/5, plus 3/5, which is 8/5, divided by 2, or times 1/2. 8 divided by 2 is 4. We should know the square root of 4, which is 2. So here's the answer. Rationalize the denominator to get negatives. I guess I'll put the negative in front. 2 times the square root of 5 over 5. And that is it. All right, so there's 2 delta math links to practice with the double angle formulas and with the half angle formulas. Good luck.